Good afternoon, 8th grade. This is our notes on the number system. It's going to be page 15 in your notes. And we're going to start off by talking about a type of number that's called a not real number, not real, which is kind of a weird thing to say. But the first, we'll look at an example, and I think it will help you see what we're talking about. Our first example is going to be a number where you're dividing by 0. So 6 divided by 0 as a fraction, or we're using our division symbol here. And the idea with this is that there's really no way to take an amount and make it become nothing. It's kind of impossible to do that. You could split it up, you could maybe take some of it. Well, you can't make it become nothing using division. So you can't take an amount and divide it up into enough pieces so that there's nothing there. There's always going to be something there. So we can't have this situation. So anytime you would see this, you would say this is not a real number. This is impossible. That's why we call it a not real number. The other type of number is going to be a square root of a negative number. So we have 3 examples here. Now, the reason these are not real is because if you remember what a square root is, it means a number multiplied by itself. And if you go back to your signs rules for multiplication, any number, well, if you have a negative times a negative, you're always going to get a positive, right? You only can get a negative answer if it's a negative times a positive. So there's no way a number multiplied by itself would be a negative answer, because a number like, say, -2 times -2, that's going to be +4. So there's no way you could multiply a number by itself and get a negative answer, because it's always going to be a positive times a positive or a negative times a negative, and your answer will be positive. So square roots of negative numbers cannot exist, so we say they're not real. These are the 2 types of not real numbers, and you should, in the future, we're going to ask you to give examples of both types, so try to remember this stuff. Our next type of number we're going to talk about is a real number. It's a number that actually exists, and under this category, real numbers, there's 2 types. One is called an irrational number. Now, the idea with a rational number is that it's going to be a number that goes on forever. So we talked about pi before. Pi is the ratio of diameter to the circumference of a circle. This would be a number that would go on forever. So it would be 3.14, and then it would just keep going on forever, and there's no pattern. It would just keep going on. You would be writing forever. So the idea is that that's irrational. That doesn't really exist. Well, it does exist, but you can't write it as a decimal. It's an approximation always, which seems kind of weird, and that's why we call it irrational. Now the other one is going to be a square root of a number when this isn't a perfect square root. So 2, that's not a perfect square root. The perfect square roots are square root of 1, square root of 4, square root of 9. Anything in between, if you put this into your calculator, what you're going to see is just a bunch. You're going to see a decimal that kind of goes as far out as your calculator allows. And if it could keep going, it would go on forever. Because again, it's going to be the same situation as pi, where it's going to go on forever, and it's not going to have any sort of pattern. So it's also irrational. These are the 2 types of irrational. Well, there's more. Pi is the most common one, and square root of non-perfect squares are the second most common. And for now, that's all you need to know. And then the other type of real number is called a rational number. So inside of real, we have irrational and rational. Rational numbers can be lots of different things. They can be fractions, they can be decimals, they can be decimals that repeat. So 3 repeating, or it could be 2 digits repeating, like 36 repeating. Square roots of perfect squares. Those are also rational numbers. So we have not real, which is dividing by 0, or square root of a negative number, and then we have real. Inside of real, we have irrational and rational. Okay, go and turn over. Now, inside of, here, let me put a, we don't want to get too far ahead. Right. Okay. Inside of the rational numbers, we have integers. So integers are numbers that are not fractions. They are not decimals. So it's going to be just 4 or 0 or 9, but they can be negative. They can be negative. So it could go from -3, it could be 7 or 8. But if there's a decimal fraction, it's not going to be a rational number. I'm sorry, it's not going to be an integer. Now there's an even more special sort of number that is even a higher requirement than integer. That's called a whole number. Now a whole number is not going to be negative. Pretty much it's an integer that's positive. And 0 also counts. Now if you notice over here I have 8 divided by 4. When we do that math, that gets us 2. And then you think about, is it a whole number or not? Or then you classify what it is. So this would be a whole number. All right. Okay, now what we're going to do is fill out this chart. So I'll give you a second to fill that in. So this is kind of the left side of our number system. On the right side, we have our not real numbers. So in your head, if you can kind of get this system, it's going to help you with the stuff we're going to do on this lesson. So on our right side, we have not real numbers. That's dividing by 0, square root of a negative number. And then this is our left side. And these are the real numbers. It's split into two parts, irrational numbers. So like we said before, that's pi. That's a square root of a number that isn't a perfect square. So like 35. Let's do just another one. Square root of 10. Anything that isn't a perfect square inside of it, that would make it into a rational number. Now, this is where it gets a little tricky on the left side. Rational integers and whole numbers. So I'm going to start at the very center. So whole numbers. I'm going to put numbers here that are whole numbers, but they also fall inside of the integers and the rational numbers. So 3 is a whole number. It's also considered an integer. It's also considered a rational number. It's also considered a real number. So there's 4 different things you could call it. Another example would be 0. Would be 125. You could keep going just so it's positive or 0, and there's no decimals or fractions. Now an integer, up here, I'm going to put numbers that are only integers and they're not whole numbers. So if you were thinking about this, you would know that would be pretty much any negative number that doesn't have a decimal fraction. So -4, -6, -9. Just so it's negative. 0 cannot be in the integers. 0 is going to be a whole number. It's more special than just an integer. So we only want things that qualify as far inside of integers in this area. So an integer, so like -9 would be an integer, a rational number, and a real number, because it falls inside all of these. Now rational numbers, those are pretty much going to be fractions and decimals. So 1/3, 6 4/10 can be a negative, that sort of thing. So it's something that terminates. So like 6.4 terminates. It doesn't keep going on forever. However, if it does go on forever repeating, it does count. So like 1.4 repeating, that will be a rational number. Okay, go and turn over to the next page. Now what we're going to do is we're going to have to name each number. So this, if you remember from our front page, is the sort of number that isn't real. It's not real because we cannot break up 3 into a situation where there's nothing. There's always going to be an amount there. If a number is not real, that's all it is. It's just not real. So what we're doing here is we're saying all the names that apply. So all names that apply. The only name that applies to this number, 3 divided by 0, is not real. Okay, coming over here. Number 2. Always start at is it real or not real. So this number, we know it's real because it's not a square root of a negative number or dividing by 0. So first we say real. Okay, now, if you look back here, all of our real numbers are going to either be irrational or rational. So looking at this number, we know it is rational. It's rational because it terminates. That decimal stops. So that would be a rational number. Now from here, the next level would be, is it an integer? Now because there's a decimal, it's not an integer. So we would say that this number is only a real number and a rational number. We don't go any further. Number 3, you can always start, is it real or not real? Because this is a square root of a positive number, it is real. Now, inside of real numbers, it's irrational or rational. Square root of a number that isn't a perfect square is called irrational. And at this point, inside of irrational numbers, you're pretty much done. There's no other classifications. It's just an irrational number. It's real, it exists, but it's irrational. It would never, you could never write the answer to this. It would keep going on forever and never repeat or have a pattern. All right, so I want you guys to do 4, 5, and 6 on your own. And we're almost done. Actually, you know what? We're going to save the rest of this for tomorrow because the next part gets a little tricky and the video is already kind of long. So just do 4, 5, and 6 on your own, and we'll go over those tomorrow and finish up the bottom part of this. It won't take too long in class. All right, that's it.